a consultant with A2K Technologies, and my background is in mechanical design. I'm a mechanical engineer and I've worked in industries such as petrochemical, biomedical, and special purpose vehicle design. With A2K Technologies I focus on Inventor, mechanical design, simulation, and data management products. So today's webinar we're going to just give a brief introduction about A2K Technologies. We're going to then focus on the tube and pipe design aspects of Inventor, and then we'll give a look and see what the cable and harness functionalities of Inventor are, and then we'll just wrap it up and leave some time for questions and answers at the end. Okay, so just first of all about A2K Technologies. We're an industry-leading solutions provider, so very large company with over 150 staff based across Australia, New Zealand, and China. We're the top-level Autodesk partner, and we're the largest channel partner in Australia. And we've got a lot of technical staff who come from industry and are experts on the products they cover. So we're obviously an Autodesk product reseller, but we also cover products that can offer an entire Office solution, such as Microsoft products. Symantec Global E-Training is an excellent product for getting your skills up to speed on Autodesk products. We don't just sell software, so we provide consulting solutions, training solutions, things like this, such as webinars, white papers, tips and tricks, and so on, as well as hardware support and IT services. We are one of the largest Autodesk resellers, so we do have the ability to deliver more. That's where we provide value to our clients. We also work very hard to make sure that the Autodesk solutions and the software solutions we provide are working well for our clients. So let's give a look at the tube and pipe design aspects of Inventor. So when we say tube and pipe design, the things we want to work for or design into our product typically are rigid piping, hydraulic hosing, or hydraulic tubing. So there are three different aspects we can do inside the tube and pipe module within Inventor. So if we switch over to the modeling environment in Inventor, we can see we've got an assembly that's semi-complete. So we've got some hydraulic hosing in here already. What we want to do is put in some more piping and finish off the hydraulic hosing aspects of this design. So what we'll do is, there's already a tube and pipe run assembly inside here. So what we want to do is we want to make sure we've got the correct style selected. So we can select the style we want to work with up here in the top left-hand side. We can pick on the ASME, ANSI, so on, and a large range of styles and standards to pick from. So in this case, I'm going with the ANSI/ASME B36.19M. And what I want to do is create a pipe run. So within the pipe run, we can create routes. So in this pipe run, I'm going to create a route. And I'm going to start on the bottom of our table leg here. And I'm going to create a piping system such that it goes up to the top of the table. So you can see there that I'm just picking, picked two incorrect edges, so I'll just redo that. What I can do is I can pick the start point of a pipe run, pick the end point, and press space bar to reverse the directions if I need to. So that's my very first one. That's using the auto route functionality. So for example, if I say finish route and then populate route, it'll put in the pipe fitting to fill that route path that I've created. And you can see there it's picking up the style that I've selected up here as well, and that comes from our tube and pipe styles. You can see here that the pipe style I've selected is in bold. We've also got a wide range of styles we can pick from that come out of the box, or we can also customize our own styles as we need to. Okay, So let's start building up the rest of this routing system, and let's maybe start working from the top down. What I'll do is, instead of just using the auto route, use a little bit of manual design just to show you the flexibility that we can use inside in the tube and pipe environment. So again, I'm picking the start point, and what I can do is I can punch in the dimensions for the end of the first section. And if I know that I want to put in perhaps a fitting at that point, I can go to Content Center panel up here in the top left and say Place, and that will give me access to Inventor's Content Center library. And then I can just go to the relevant part that I need, so tube and pipe, fittings, T's, and it's an ASME B16.3 class 150T is what I'm going to work with. And I'll just have to tell Inventor where I want to place that fitting once I select the size. So we're going to work with 1/2 inch pipe. I pick the connection point, and I also want to rotate it 180 degrees so that it'll line up with the other manifold block nicely. Okay, so what I could do once that fitting is placed, I can continue to create my routes to finish off my system. So what I'll do is I'll put a route from here, and again I'll use the auto route functionality, and I'll accept 2 segments, which is the minimum distance, and I'll finish that route, and then I'll put in another route, excuse my pronunciation, and we'll get the last part of this pipe run complete. So you'll see there, using the auto route functionality, we've got some good options presented to us, and if we don't like the default one, we can toggle through and get different variations. So you can see there I've got my route selected. So once I finish that, I can click on Populate Route, and it'll populate the 3 routes that I've been working on. That's a very nice feature because you can put in it puts in your elbows automatically for you, which means you don't have to do a lot of constraints placing parts or placing different lengths of pipe. So let's say that's our run complete for the solid pipe we're working with. So we can click Finish Tube and Pipe Run, and let's change our style. Let's change our style to let's say 1/4 inch male taper thread to finish off the hydraulic fittings on the top of this assembly. So again, the same procedure. I'll click Create Pipe Run, tell Inventor that I want to create a new route, and tell it the 2 different points that I want to route to and from. So when I click on Route, you'll see that the fitting can be changed by pressing spacebar on the keyboard in terms of its orientation. So I'm happy enough with the default one, even though I could, if I wanted to, define more points along that spline. But I'm pretty happy with the default, so I click OK. And I'll finish that route and put in 1 more. And we'll keep the style the same, which is our 1/4 inch hose, male taper thread. And we'll finish off that second route. And again, I'll accept the default route path and finish route, and again we can populate the route. So you'll see there it's quite quick and easy to create hydraulic hoses, and it spares us having to create sweeps and so on and so forth. Okay, so that's how we can insert pipes and hoses using the tube and pipe environment within Inventor. The next thing I'd like to look at is how to put in hydraulic tubing. And in this exercise we'll see how we can manually adjust the route path using different tools within Inventor. So again, we'll go to our tube and pipe runs, and this time our style is going to be steel hydraulic tubing, 3/8 inch. And I'm going to create a pipe run. And our route is going to be from this hydraulic pump up to our valve. So again, I'll click on route, zoom in, and okay, you can see there my document settings are in inches at the moment. So what I'll do is I'll just go back up to my document settings, and change the units to millimeter to make sure I've got the correct unit system in my assembly. Okay, so once that's done, I can go back to my route panel and I can say route again. And what I want to do is create a route from the diaphragm pump out, and the distance I want to come out is 75 mil. And once I'm out 75 mil, I can then choose to rotate the axis up 90 degrees. And now I can leverage off existing geometry in the model by right-clicking and say point snap. And by clicking on a plane like that, I can punch in the offset above the plane that I want the route to go. And you can see there the route has gone 25 mil, the upward direction above the plane that I selected. So if I want to connect this point up to our valve up here, I'm going to need to use maybe construction geometry so I can get intersecting lines. So using construction geometry is quite a useful feature in the tube and pipe environment. So I can select a node, right-click and say draw construction line. And I'll just look in at this side. And I'll turn my triad again, this time 60 degrees. And I'll punch in the distance 500 mil, which draws a construction line 500 mil at 60 degrees to our point. Next step then is I can create the route from the top, from the valve down. And I'm going to come down 100 mil distance and use another feature inside my tube and pipe environment called rotation snap. So with rotation snap I can click on an existing line and the axis will rotate to snap to that line. So then I can continue my route and pick up on that construction line that I've placed. So then to finish off our route, I just simply click on the, say, finish route for a second, and then click new route again. And I could have actually just continued on with the other route, but my mistake. So yeah, that's what I think I'll have to do. So I'll say finish route, and we'll delete this second route and go back and work on our unfinished route here. So what I want to do is just use the auto-complete with one segment. Happy with that. And you'll see it puts in the fillets nicely for us as well. So now we've our route complete. We can go on, click Finish Route. And again, we'll populate our route using our steel hydraulic tubing style. And once I turn off the visibility of the route, we'll get rid of our construction line. You can see that we've got a nice complete hydraulic tubing line routed from the valve to the pump. So there's some nice little features there like the point snap and rotation snap that we use to create that route. So let's finish out of the tube and pipe environment and we can close it and move on to our, just back to our presentation again. So we've seen the three different aspects of types of tube and pipe and hoses that you can create inside the tube and pipe environment within Inventor. But you can also take that assembly and then flow it through to Showcase to create photorealistic renderings of your model. So Showcase is a really useful tool. It's quick and easy to learn. It doesn't take long to learn and you can get really good results really quick from the program. So moving on to cable and harness design. So there is functionality between there is associativity, and you can get your data from an AutoCAD Electrical schematic and bring it into your 3D model such that your wires are routed automatically in your 3D space and all the correct data is coming from your 2D schematic into your 3D model. So we'll move back over to Inventor and we'll give a look at the cable and harness environment. So here we've got a cable and harness, a power box. And what we want to do is create a couple of wires from our red connector here to our blue connector over here. So going into our cable and harness module, We can create some wires, and again we can pick from standard libraries, and your own custom library can be added in there as well. So I'm going to add a few wires, and then Inventor just needs to be told where the start pin is and where the end pin is. So we can click apply, and we can link up a few more pins just to put in the wires that we need. And you'll see there what's coming up excuse me, what's coming up as I'm selecting on the electrical component. You'll see that U is the reference designator for that part. So U with pin 8 going to U, again reference designator hasn't been specified, to pin 1 on that part. So we can click apply, cancel, and what we want to do then is insert a segment. And the segment is where we route our wires through. So it's really like a cable sheet, pretty much. So what I'm doing is I'm picking up on existing work points that are in the components that I want to route my segment through. This makes it very easy to create a segment path. And you'll see the segment is sweeping through the center of my cable ties nicely and creating a nice spline. So again, this spares you if you weren't using the cable and harness environment, you'd have to draw a line and sweep a path through the line. Whereas here we've got our segment already put in place. We can right click and say finish. And then we can tell Inventor to automatically route all unrouted wires. And the wires get routed through our segment. So you can see it looks nice and tidy there. So there's some nice design accelerators and productivity enhancers within the cable and harness environment. You can specify where your wires are going to and from. You can put in a segment and then route the wires through the segment. The next thing I want to talk about within the cable and harness environment is the ability to import data from AutoCAD Electrical. So if you are working in AutoCAD Electrical and you want to transfer the data from AutoCAD Electrical into your 3D modeling environment, what you can do is you can import your data using the Manage panel here and import harness data and navigate to the file type that you want to import, which is going to be an XML file. So when you're in AutoCAD Electrical, you can export your design as an XML file. You can see here that I've got Autodesk Inventor Professional Wireless Import. Click Open and OK. And as we import the data, we can review what we're importing. So you can see here that X4, the reference designator X4, has a wire connecting from pin 1 and 3. So what we can do is we can right click and we can say assign this to an existing electrical part. And as we hover over the parts, you can see here we've got the different designators that are associated to each part. So I want to assign that electrical part to this. And I can continue to navigate and make sure that my data that is importing from AutoCAD Electrical meets up and corresponds with data within the electrical library inside in Autodesk Inventor. And you can see here there's one wire that's not been associated correctly, so I can right click and I can say choose from our cable and harness library because it doesn't have any P&K 16 average wire gauge. So what I could do is go to the generic library and say instead of giving it a pink 16 wire gauge, let's go with 16 wire gauge and let's go red, which is the closest, I guess. So then we can click OK. And Inventor gives us a log saying there's no errors or no warnings, so we can close that. And we can see that our wires have been imported successfully. So then to finish off that design, we'd again create our segments and route our wires through those segments. So there's some very nice functionality between Autodesk AutoCAD Electrical and Inventor Professional. Okay, so that's pretty much the functionality that we wanted to go through. Whoops. For our cable and harness design. So you can see you can bring in your data from AutoCAD Electrical into your 3D modeling environment and work with it within a 3D space. So that's pretty much my what I had planned to cover today in terms of our Inventor routed systems. So we covered off the basics of tube and pipe assemblies very briefly. You could see how we could create pipes using our automatic routing tools as well as using our manual routing tools. So for our tubing, we mapped where the route would go from our pump to our valve. Then we dropped over or switched over to our cable and harness environment, where we showed how to create some wires between electrical connectors, how to map a segment between those connectors, and then how to route the wires automatically. We also talked about the way AutoCAD electrical data can be imported into Inventor Professional via an XML file, and how we can make sure that all our data, our reference designators, our pin numbers, our wire types are correctly associated to our model data within Inventor. So that's pretty much it for today. Thank you very much for your time, and I look forward to the next webinar.